Hello, this is Corbin, and this is my homework 2 video assignment for acids and bases. So the question I'm going to cover in this video is question 4 of the worksheet. Right, we have leucine here, an amino acid with 2 functional groups of interest, that OH group on that carboxylic acid with a pKa of 2.36 and a leucine with a pKa of 9.60. Let's get into the individual questions. There's 3 of them. So in part A, we're asked to draw leucine in a solution that's at pH 11. So how I went about solving this is at a pH of 11, we know that there are lots and lots and lots of hydroxide ions because any pH above 7 indicates that there's more hydroxide than hydronium or hydrogen ions, right? So what's going to happen here is those free-floating OH ions are going to rip off the hydrogen on both the OH on the carboxylic acid and on this NH3 group here. It's going to rip off one of the protons, right? So what we're left with is the carboxylic acid that's deprotonated and the NH2 group that has no more protons on it, so it was deprotonated. Moving on to part B, we're told to draw leucine at a pH of 7.4. So it's kind of harder to just eyeball this one without pKa values. So with the OH pKa, it's 2.36, and the NH3 group pKa is 9.60. So what does this mean? When we look at the transformation here, we're going to only lose the proton on the OH group on the carboxylic acid. And why is this? Well, the pH of the solution is less than the pKa of NH3, meaning that this solution already has enough hydrogen ions donated, so NH3 isn't going to really want to add more to that. And with the OH group, or what was the OH group, is kind of the opposite. That OH group would prefer to get that pH down to 2.36, right? But it's not there yet. It's at 7.4. So it's going to keep deprotonating until it gets that, or it tries to get that solution down to 2.36. And for part C, we're told to calculate the isoelectric point when there's no net charge. So there's a simple formula, right? Add up all the pKa values and divide by the number of pKs you have. So, for example, here we have the hydroxyl group and we have the NH3 group. Add up their pKa values, divide it by 2, and you're left with 5.98. So at the pH of 5.98, there's going to be no net charge on leucine. Thanks for watching, guys.